Welcome to our journey through the Milky Way galaxy. Look up on a clear dark night, far from the glare of city lights, and you might glimpse a faint luminous band stretching across the heavens. That, my friends, is our home galaxy, the Milky Way, seen edge-on from our vantage point within one of its spiral arms. It's a structure of such immense scale and breathtaking beauty that contemplating it can fill us with a profound sense of wonder. A feeling of connection to something truly ancient and unimaginably vast. Today we're diving into 10 fun and fascinating facts about our cosmic neighborhood. We'll embark on an exploration that takes us from the intricate structure of our galaxy to the mind-bending phenomena that occur within it, and even beyond, to its place in the grand cosmic tapestry. Think of this as your personal tour, a chance to become more intimately acquainted with the stellar city of which our solar system, our Earth, and indeed ourselves are but a tiny yet precious part. The universe beckons, and our own galaxy holds countless secrets. Understanding the Milky Way isn't just an academic exercise, it's about understanding our origins, our place in the cosmos, and the fundamental laws that govern existence. Every atom in your body was forged in the heart of a star long ago, a star that was once part of this very galaxy. So let's peel back the layers of cosmic dust and interstellar gas, and gaze upon the marvels of the Milky Way. Prepare to have your perspective shifted, your curiosity ignited, and your appreciation for the universe deepened. Our Milky Way is not just any amorphous blob of stars, it possesses a distinct and elegant structure. Astronomers classify it as a barred spiral galaxy. Imagine a vast, spinning pinwheel, but with a crucial addition: a bright, elongated bar-shaped structure composed of stars and gas cutting through its very center. From the ends of this bar, majestic spiral arms, rich with young stars, gas, and dust, unfurl and sweep outwards into the cosmic dark. This central bar is not merely a static feature, it's a dynamic engine, channeling gas and material towards the galactic core, potentially fueling starbirth and feeding the monstrous black hole that lurks there. This barred characteristic distinguishes the Milky Way from regular spiral galaxies, which have arms that appear to emanate more directly from a spherical central bulge. Other galaxies, of course, come in different cosmic flavors. Elliptical galaxies, which are more ovoid and generally contain older stars, and irregular galaxies, which, as their name suggests, lack a defined shape. The presence of the bar in our galaxy has profound implications for its evolution, influencing how stars are formed, how gas clouds are shepherded, and the overall gravitational dynamics that sculpt its breathtaking form over billions of years. It's a testament to the universe's ability to create order and complexity on the grandest scales. Contemplate for a moment the sheer number of stars within our galactic home. Current estimates suggest the Milky Way contains over 200 billion stars. Some astronomers even propose figures as high as 400 billion. Let that number sink in. 200 billion. If you were to count one star every second, it would take you over 6,000 years to count them all. Each one of those points of light, or potential points of light, is a sun, a colossal fusion reactor, many of which could, in principle, host their own planetary systems. Our own sun is but one citizen in this immense stellar metropolis. And these stars are not all identical clones of our sun. They exhibit a staggering diversity in size, mass, temperature, color, and lifespan. There are the tiny, dim, and incredibly long-lived red dwarfs, which are the most common type. Then there are stars like our Sun, a G-type main sequence star, relatively stable and middle-aged, and then you have the celestial titans, the brilliant blue giants, burning through their fuel at a furious pace, destined for spectacular supernova explosions, not to mention the exotic stellar remnants like white dwarfs, neutron stars, and even black holes born from the collapse of massive stars. Our galaxy is a veritable cosmic zoo of stellar wonders. Just as cities have neighborhoods and streets, our Milky Way has its own distinct regions. We reside not in the bustling galactic downtown, nor in the remote cosmic suburbs, but in a relatively minor spiral arm, or perhaps more accurately, a spur, known as the Orion Arm, or sometimes the Orion Cygnus Arm. This structure is nestled between two much larger grand design spiral arms, the Sagittarius Arm, located closer to the galactic center, and the Perseus Arm, further out towards the galactic edge. Our solar system is currently traversing through this less crowded but still vibrant region of space. The Orion Arm itself is about 3,500 light-years across, and approximately 10,000 light-years in length. Within this arm, our Sun, along with its family of planets, orbits the galactic center, completing one grand circuit, a galactic year, roughly every 230 million Earth years. Our position within the Orion arm is somewhat fortuitous. We are far enough from the turbulent galactic center to avoid its intense radiation and gravitational disturbances, yet we are within a region still rich enough in heavier elements, forged in previous generations of stars, to form rocky planets like Earth. It's a relatively calm, habitable zone on a galactic scale. The Milky Way is vast, almost incomprehensibly so. Its main stellar disk stretches approximately 100,000 light-years in diameter. Now, what exactly is a light-year? It's the distance light, the fastest thing in the universe, travels in 1 year, about 9.46 trillion kilometers, or nearly 6 trillion miles. So, to cross our galaxy from one edge to the other, even if you could travel at the mind-bending speed of light, it would take you a staggering 100,000 years. Our fastest spacecraft, like the Parker Solar Probe, would take hundreds of millions of years to make such a journey. To put this into perspective, our nearest large galactic neighbor, the Andromeda Galaxy, is about 2.5 million light-years away and is itself even larger, perhaps 220,000 light-years across. Compared to many other galaxies in the universe, the Milky Way is a substantial, mature system. Its thickness varies, being about 1,000 light-years thick at the stellar disk where most stars reside, but its halo of dark matter and sparse stars extends much further. Contemplating these distances challenges our everyday intuition about space and scale, reminding us of the sheer grandeur of the cosmic arena in which we exist. At the very heart of our Milky Way, shrouded by dense clouds of gas and dust, lies a monster. A supermassive black hole named Sagittarius A*, pronounced Sagittarius A star. This isn't the kind of black hole formed from the collapse of a single star. Sagittarius A* is a true behemoth, possessing a mass equivalent to about 4.3 million times that of our Sun, all condensed into a region smaller than the orbit of Mercury. Its gravitational pull is so immense that nothing, not even light, can escape its grasp once it crosses the event horizon. How do we know this invisible giant is there? We can't see it directly, of course. But astronomers have meticulously tracked the orbits of stars very close to the galactic center for decades. These stars whip around an unseen, incredibly massive object at tremendous speeds, some reaching several percent of the speed of light. Their precise Keplerian dances provide undeniable evidence for the mass and location of Sagittarius A*. While currently relatively quiescent, supermassive black holes like ours are thought to play a crucial role in the evolution of galaxies, influencing star formation and the overall structure of their cosmic homes. Our Milky Way galaxy doesn't drift through the cosmic void in splendid isolation. Instead, it's a prominent member of a gravitationally bound collection of galaxies known as the Local Group. Think of it as our immediate galactic neighborhood, a relatively small cluster spanning about 10 million light-years across. This cosmic family consists of more than 80 members, though most are diminutive dwarf galaxies, faint and difficult to detect. Gravity is the great sculptor of the universe, and it's gravity that holds the Local Group together. The undisputed heavyweights of the Local Group are our own Milky Way and the Andromeda Galaxy, M31. These two majestic spirals are the largest members, each with its own retinue of satellite galaxies. The third largest member is the Triangulum Galaxy, M33, another spiral, though considerably smaller than us or Andromeda. Other notable members include the Large and Small Magellanic Clouds, which are satellite galaxies of the Milky Way, easily visible from the southern hemisphere. The Local Group itself is just one small part of an even larger structure, the Virgo supercluster, demonstrating the hierarchical clustering of matter in the universe. Nothing in the universe is truly static, and our Milky Way galaxy is no exception. It's not just rotating. The entire galaxy is hurtling through intergalactic space at a breathtaking speed of approximately 600 kilometers per second. That's about 2.2 million kilometers per hour, or 1.3 million miles per hour. This incredible velocity isn't measured relative to nearby galaxies within our Local Group, but rather with respect to the cosmic microwave background radiation, the faint afterglow of the Big Bang, which provides a sort of universal reference frame. So, where are we rushing off to in such a hurry? This motion is complex. a combination of gravitational tugs from various massive structures. The local group, including the Milky Way, is being pulled towards a region of space known as the Great Attractor, a gravitational anomaly located in the direction of the Hydra Centaurus supercluster. Beyond that, an even larger structure, the Shapley supercluster, exerts its influence. This cosmic flow, this constant motion, underscores the dynamic nature of the universe, a universe in perpetual evolution where galaxies, stars, and even space-time itself are constantly interacting and changing. Prepare yourselves for a truly cosmic spectacle, though one that won't unfold for quite some time. Our Milky Way galaxy is currently on a collision course with its largest neighbor, the Andromeda Galaxy. Andromeda is hurtling towards us at a speed of about 110 kilometers per second, roughly 400,000 kilometers per hour, or 250,000 miles per hour. Based on current astronomical data and sophisticated simulations, this galactic rendezvous is predicted to begin in approximately 4.5 billion years. It's a destiny written in the laws of gravity. Now, when we say collision, don't picture two solid objects smashing into each other like cars in a demolition derby. Galaxies are mostly empty space. While the gravitational forces will be immense, the chances of individual stars colliding are incredibly remote. Instead, the two galaxies will pass through each other, their structures distorted by tidal forces. Over hundreds of millions, perhaps billions of years, they will dance around each other, eventually merging to form a new, even larger galaxy, often whimsically dubbed Milkomeda or Milkdromeda, likely an elliptical or lenticular type. Our solar system will probably survive, albeit finding itself in a very different and perhaps even more spectacular night sky. Just as planets can have moons, large galaxies like our Milky Way can have smaller galaxies orbiting them, known as satellite galaxies. These are dwarf galaxies, gravitationally tethered to their more massive host, like cosmic tugboats accompanying a giant ocean liner. The Milky Way is currently known to have dozens of such companions, ranging from relatively bright and well-known systems to incredibly faint, diffuse collections of stars that are very difficult to detect. These satellites offer invaluable clues about galaxy formation and the nature of dark matter. Among the most famous of these are the Large Magellanic Cloud and the Small Magellanic Cloud, irregular dwarf galaxies easily visible to the naked eye from the southern hemisphere. They are vibrant with star formation, a result in part of their gravitational interactions with the Milky Way. Other satellites include the Sagittarius Dwarf Spheroidal Galaxy, which is currently being tidally disrupted and cannibalized by the Milky Way, its stars being stretched into long streams that wrap around our galaxy. Discoveries of new ultra-faint dwarf galaxies continue, painting a picture of a rich and complex galactic ecosystem. Our Milky Way is not a static relic, it is a dynamic, evolving entity that has been actively forming stars for an astonishingly long period, over 13 billion years. Its story begins in the early universe not long after the Big Bang itself, which occurred about 13.8 billion years ago. From primordial clouds of hydrogen and helium, the first generations of stars ignited, and our galaxy began to take shape, growing through mergers with smaller protogalaxies and the continuous accretion of intergalactic gas. This stellar birthing process continues even today, though at a more sedate pace than in its youth. Within vast cold clouds of molecular gas and dust like the famous Orion Nebula or the Eagle Nebula's pillars of creation, gravity slowly coaxes material together, eventually reaching temperatures and pressures sufficient to ignite nuclear fusion, and new stars are born. Each generation of stars enriches the galaxy with heavier elements forged in their cores and dispersed through supernova explosions. It is from this cosmic recycling, this stardust, that planets like Earth and ultimately life itself are made. We are, quite literally, children of the Milky Way's enduring creative power. Thanks for joining us on this cosmic adventure. We've journeyed from the grand spiral arms of our galaxy to the supermassive black hole at its heart, from its countless stars to its inevitable dance with Andromeda. The Milky Way is more than just our home. It's a laboratory of astrophysics, a testament to the enduring power of gravity and the intricate processes that shape the universe. Each fact we've explored is a brushstroke in a much larger, more complex portrait that scientists are still diligently painting. The sheer scale and beauty of our galaxy can be humbling, reminding us of our small place in a vast cosmos. Yet, it should also be empowering. We, creatures of this galaxy, have developed the capacity to look out, to question, to understand. The quest for knowledge is a journey without end, and the Milky Way still holds innumerable mysteries waiting to be unraveled by future generations of explorers, thinkers, and dreamers. May your curiosity always guide you to look up and wonder. If you've enjoyed this voyage through our stellar neighborhood and wish to continue exploring the wonders of the universe with us, please show your support. Don't forget to like, subscribe, and hit the bell icon for more amazing space facts. Until next time, keep your eyes on the stars and never stop asking why.